Hi everyone. Today we are going to discuss about intelligent coding. Um, well, so far we looked at the secure codings, right? We spent about quite a good amount of the works, how we can make our systems secured when we developed, when we maintain our security programs. Now, we want to switch our gear to the intelligent codings um, so that we can solve the problems intelligently. There are two things that you may imagine when you hear intelligent coding. The first thing that you can think is how some of the intelligent systems can code on behalf of me. Okay, that is also widely speaking uh, when we hear about OpenAI and ChatGPT, then some of the coding lists can be generated by the ChatGPT. That is quite true. Um, the things that ChatGPT can provide you is not the way that ChatGPT uh, code something for you by himself. Rather, what ChatGPT can do is to gather some of the coding list already collected and pick the best ones and modify a little bit to accommodate uh, any questions. That is what the current ChatGPT can do. Okay, so that is coding. So coding itself can be done by uh, some of the codes. Okay, some of the programs can code. That is intelligent codings. Another aspect of uh, intelligent coding is that how can we solve the problems intelligently? That is also things that ChatGPT, not really ChatGPT, OpenAI can do. Or recently, um, if you remember that many years ago, probably 5 years ago, AlphaGo, the program, defeated the human player. Um, there's a Go game, right? Um, it's like a board game, uh, a lot complicated than chess. Chess is a simple the board games, but Go game is almost unlimited possibilities available. If anyone do not understand it, have anyone who hasn't um, seen the board game of Go, you may be able to find out from somewhere, or you probably heard the news about 5 years ago, right? That is the Go game. Usually, it is very popular in, uh, for example, South Korea, Japan, China, those three countries. AlphaGo game, when AlphaGo the software uh, played with the human champion. It was taking place in South Korea, and then they defeated the guy, uh, the Korean player. But anyway, that type of things is a problem solving, right? Uh, some complicated problems can be solved intelligently, more intelligently than what human can do. That is also um, the intelligent codings. Okay, so this module actually consists of two things. So today we will look at here. So how we can, how a program can code. Okay. For example, a Python code can generate yet another Python code. That is intelligent codings. So this is more difficult ones rather than the other ones here. Problem solving, intelligent problem solvings, like ChatGPTs. So this week we will look at this, and from next week we'll go this way. There is a hot topics in computer science, so-called machine learning. One of the intelligent machine learning is deep learning. Deep learning. So we'll look at, start with the machine learning, and then we'll look at deep learning. All of this, we also provide hands-on labs. Same thing here, hands-on labs. All right, so today we'll look at this. So intelligent programmings, I ask you to read all of this, and then we'll jump directly to the hands-ons. I posted IPYNB Google Colab, so we'll look at that one first, and then OpenAI, how our Python code can include OpenAI. So our Python code can access OpenAI to give to you the answer. To do that, we need to have API the modules, which requires a key. I'm not asking you to get the key, but if you are, or if you can afford to, or if you are interested in, then you can buy API key from OpenAI. I bought, this is it's a memberships. So every month, I think I paid $40 for OpenAI. That's only for the purpose of my lecture, from my pockets. I'm not sure the university pays for that. Probably not. But anyway, so that is from my own. And also I not only use this, but I'm teaching the graduate course where the students can develop iPhone apps. Then some of the modules of the iPhone applications could be using OpenAI. So anyway, I am using for not only for this class and the other class as well. So I'm okay. So I'm telling you how this can work. This should be run on Windows or Paizo. This OpenAI program cannot run on Google Colab. Remember that Google Colab is another cloud computing. And OpenAI is another cloud computing. If I have a program running on a Google Colab, that's cloud computing. That cloud computing doesn't go to another cloud computing directly. Okay, so we don't do here, but on my laptop. As far as OpenAI program available on your laptop, then you can run on any IDE, but I am using Paizo. Or even you can simply run your Python program on command line on the terminal. That is possible. So I will do this first, and then secondly, this OpenAI. All right. So push this aside a little bit. Let's see. So we'll look at some codes are provided to you. Okay, you don't. This module doesn't ask you to do any codings. Okay, simply think about it. Okay, I provide you three the program segments. All of those can generate the code. So first one is a template-based code generations. And the next one is a rule-based code generations. And third one, this is not really something that compared with the other two, but I want to generate object-oriented codings. So class, methods, and things like that. So that is also possible. Okay, so let me explain the code quickly, and then we practice it. Define a function, generate a function code. It can take function name, parameters, return type, and logics, and then we formulate function code. Then it should generate the DEF and function name, open parentheses, and a list of parameters, close parentheses, and colon. And then we have the logics inside. And then finally, we return this function code. That can be run by, so this is the function definitions, and this is a function invocations. So in this main program, we can ask, enter the function name first, and we collect parameters from user, and then we collect the return type from user, and then finally ask logics. Enter the logic for the functions, okay? And then get the logics, see here, yeah, so line, until we have done, then we collect all the lines of logic into so-called logic list, and then we generate that once. Okay, so what we need to do is that we need to run this function definition first, and then invoke that function. Then it asks us to say average. Let's say sum. And then enter parameters, comma separated. Then we can say A, comma, B, comma, C, comma, D. And then the return type is, say, out. And then what is the logic? The sum of the logics is out equals A plus B plus C plus D. That is our logics. And then you could have a multiple logics, but in this case, in my case, only one line. Then we can make done, and it generates the code. df sum, it takes A, B, C, D, and out is that. So we can practice that if it works. So take this out here, and then we can call that, for example, sum and 1, 2, 3, 4. Then we can run. Then it returns 10, right? So this is quite true, right? This is executable. This is a correct code that was generated by this Python code. This Python code can generate another Python code. That's what it is, right? You can practice this, for example, not only this, not only one line of logics, but multiple logics. If we say average, then you need to first get the computation of the sum, and then you need to divide the sum by number of the parameters here, and then that is averages. You can extend further and further, right? For example, like this, average, then say the parameter A, B, C, D, and then return type is average. And then logic is, first you can say sum equals A plus B plus C plus D, and then average equals sum divided by 4. There's 4 parameters. I put there hard-coded, but you can do some others if you want. And then done. Then it generates this. Let's see if this works. Then I can copy this back here. And then if I run here, average, see what happens. Then average is 2.5. I believe it is a 2.5, right? So this kind of things can be generated. So this is a template based. So problem of from this the code. Copy the code generated at your best runs. So you can practice more and more, little more complicated ones. I would say best case, right? And then test code like this. This is test code. Try to make sure use cases for the template-based generation and see any limit that you have. So far, there is no limit, right? But as you extend this more and more for the little more complicated computation, then you may, I mean, this code is not really perfectly intelligent coder, right? So there may be some limits. What is the limitations? So you need to describe the limitations with some of the examples that you used here, right? For example, hey, this kind of code I ask to generate, but the code it generated was not really good enough from my test, and therefore I would say that is the limit. And then you can more formalize what is the limits, okay, in your test case. There's homework number 1 for these modules. And then the other one is the rule-based code generator. This, say, if you see this, then generate function first. So come here, and it says, welcome to the intelligent Python function generator. So this guy is only doing a function generator, either arithmetic or comparison. So ask you to choose. If it is not any of this arithmetic and comparison, then it says we want to support it. If it is not, if user choose one of these two, then next question is enter the name of the functions. And if you chose arithmetic, then it calls generate arithmetic function. If it is comparison, then it generates comparison functions. So we have two functions defined here. Arithmetic functions, then there's operators, plus minus that. And then randomly choose one of those. And then parameter is that. So randomly generated some of the code. Similarly, if it is a comparison, then there's a comparison operators. And then also randomly generates. So see how it works. If we say arithmetic, and then name of the function, then you can say adder. This is not really intelligent, right? I said adder, but it randomly it chose plus. Remember that here? Random choice of operations. I have these manys, but it chose only randomly. Even if I said adder, then plus sign should be used, right? But because this guy does not understand the language, right? If we combine that function with the ChatGPT, then ChatGPT can understand what adder means. Then it definitely give me, hey, that is a plus operator. Then we will have a better ones, right? Like this. So same thing, you can try to code the generations and test it. If there is any limits, describe this. We already see the limits, so I ask you to do that as well. Okay, so what we did so far, template-based code generations and rule-based code generations. Here are the rule-based code generations. Rules are already defined, only two things, arithmetic or comparison. But if you add more categories, like arithmetic or comparisons, something else, then it could be more and more intelligent, right? Intelligent. So that's a possible way that we can extend. Lastly, we have here object orientation code generations. So let's look at the main function first. Enter class name and attribute, enter number of attributes with the comma delimiter, and then And then the method names. So we can add more and more method names. And finally, we can generate some of the very nice object orientations. So we can try that. Enter class name. We can say student. And enter attributes. I would say major, name, major, and age, for example. And the name of the method, I would say GPA. GPA is like a function, right? So parameter for the GPA, then we can say homework 1, homework 2, and homework 3. And then what is the logic? Then sum equals homework 1 times, this is somehow the weight, right? Homework 1 is less important so that we can have the multiplications, only 20% of the homework 1s. And then homework 2, and maybe 40%. I think 30%, 40%. And homework 3, to make it 100%, then 50%. Okay, that is the sum and average. Average equals sum. Average equals sum, I think. Because already, let's say that is 100 scales, but GPA is 100. If that is a perfect, then it'll be the 4 points. So we need to divide by 25. Let's do like this. And then we can say done. That is it. Is there any other methods? Let's do done. Then we have a class definitions like this, and then we can test. Bring that up here. Copy. And then I can say student 1 is student, and we can say name John, and major cyber, age, let's say 20. Okay, then I can say st1s.gpa. Homework 1s 98, homework 2 89, homework 3 78. Okay, and then I want to print this. Print that GPAs. So what is my GPA for that? Okay, I want to run this. Oh, it should give me return. I forgot to return here, right? Average. Okay, and run. Okay, what is it? GPA text 3 opposition, but 4 given. Oh, here also I need to say self. Self I forgot. So when you run it, you need to put here self. Remember that here. Then my GPA is 3.412. Okay. So this kind of things. Same thing here. Any limits? I want you to describe this. So these modules, homeworks, 3 questions, but each for each way of the code generations. But I ask you to give me the lessons learned. Okay. So what is the limitations of each? Okay. So that is that one. And then see. Finally here, this using OpenAI. The code is this. OpenAI.key, I want you to put here your key. I believe if you pay, I think $40, then you can use 1 month. It's quite expensive, right? But anyway. And then the question is, please enter your question. Then it's invoke this, ask OpenAI question by taking questions. So it runs chat completion that creates. So use GPT 3.0 Turbo, or you can use GPT-4. So message is the role system content your helpful assistant, and that if the role is a user, then we take these question that raised by user, and then adjust token limits, and then creativity levels, and then we run that answer, get the response from the ChatGPT, and then return that answer, and then we can show that once. So in this code, I hided my API, the key that is above here. Of course, I need to, in order to do that, I need to install OpenAI. So I need to install OpenAI and run this code with the API key. Right. So I want to give you the test for this. So I can run this. Then it asks me to enter. So you can say anything. What is Python? Then, so Python is a high level programming language. Oh, this guy says there's a programming languages. I was expecting something else, like snakes. So what is when is the election day in 2024? I want to ask if this takes some timely sensitive questions. Election dates, United States for 2024 presidential election dates is scheduled November 5th. So it takes some time critical questions as well. Let's try something, the technologies. Okay, so how accurately can the fully driving on Tesla. More complicated questions, right? Let me see. How accurately can the fully self-driving module run on Tesla? Oh, long answer. Tesla is full self-driving features is an advanced driver assistant program system that is designed to provide partial automations of driving. So while Tesla is accuracy and performance of Tesla systems vary depending on factors such as road conditions, weather, and local regulations. Oh, that is quite true. Overall, Tesla full self-driving system can provide advanced driver assistant features and enhance driving experience, but it is not yet fully autonomous, and the drivers should exercise. All right, quite reasonable. Okay, so that is what I prepared for these modules. So the one part of intelligent programming considered today, which is self-codings, right? How can I make Python code, therefore can generate another Python programs? Very, very primitive levels, but it's not impossible, right? That is done. And then from next week, we'll do, in another angles, make our program can solve the problems more intelligently. So we'll go up to deep learning exercises. All right. Thank you. See you later.